Okay. We're back. And Tim and I. So here's what. Everyone ready? Moses, here we go. We are going to be doing this problem with no hints. So the problem is this. You have to figure out how to get yourself started. It's like you're on a swing set, right? And instead of me giving you a push to get you started, you actually have to kind of do a running thing to get yourself started. So the way we do this is the reason I don't like this section is the way that we get ourselves started is, honest to God, randomly kind of just guessing, right? We're going to actually kind of have to guess at where we start, which is kind of guess and check. And I got to be honest, I, as a math teacher, am not a big fan of guess and check. So this is why we're starting so early, because you are not going to do all of the guessing. You're going to assign each member of your table group a number to guess, so you can at least do this a little faster. But it turns out we're not going to make random guesses. We're not going to take a problem and feel like, I don't know, let's try 17, right? You're not going to take random guesses. There is a little bit of a system. So here's what I'm going to tell you. It is referred to as the rational zero theorem. Look at me giving scary numbers, right? But it's why the rainbow method works. This whole time you guys have been saying, I do that rainbow thing with C, but I don't really know why it works. And I am going to tell you. So you're going to watch me do this real quick. Plus 20x minus 7. So here's what. I would want to factor this dude. And I wouldn't know how to factor it because I have the number in the front. I can't suck anything out. So I would rainbow it. And what I would do to rainbow it is I would take these two dudes, right? Factors of 21 that make 20. That's going to be a positive 21 and negative 1, right? And then I'm going to do this, x plus 21, x minus 1. And then I'm going to divide it by 3. Then I'm going to divide it by 3. So my answers would be negative 7 and positive 1/3. We've done that. We've done it a lot. We did it last year. We did it this year. Yay. Here's what I want you to notice, though. These numbers that I came out with, this 20 and this 1, this 21, were not just random ass guesses. They were a combination of this guy and this guy. This answer, this 7, is a combination, and this 1/3 of this guy and this guy. That's a combination. That's not luck. That happens every single time. So what we're going to use is we're going to use that knowledge, which is called the rational zero theorem, to say, okay, if I know the first and the last number, can that at least help me figure out what guesses might work to start the process? Does that make sense? So here we go. It's weird. The first one's weird. Second one's not so weird. Third one, you guys are going to be able to do all by yourselves. You guys ready? Here we go. So it's kind of guess and check. First thing I always want to do, I've got a process here. First step, can I suck anything out to take a hard problem and make it easier? Is there an X that can come out? Or a 2 or a 7? Anything come out? No, nothing comes out. So I check that off my list. That won't work. The next thing I'm going to do is say, does that half thing work? Well, maybe I'm going to give it a shot. I'm going to take out an x squared, and I'm left with x plus 3. That feels pretty good. I'm feeling pretty happy. I'm going to take out a negative 2. I'm feeling pretty happy. But look at this. They don't match. So that didn't work. So now I'm stuck with guessing and checking, right? Now I have to guess. But I do not want to just guess a bunch of random numbers. So here's what I'm telling you. The number that will work, and there might be more than one, is going to be a combination of this guy and this guy. And here's what the combination, we call it we call it P over Q, where this is my Q and this is my P, meaning it's going to be some number that will go into 8 and a number divided by 1. Now, here's the nice thing. Divided by 1 is easy, so we don't have to worry about it. I'm going to show you what would happen if it was a weirder number. That's what they're doing in pre-calc honors. We're not going to sweat it that much. So here's what. I'm going to have to guess at my starting point, at my very first hint. So what we need to think to ourselves are, okay, what are the numbers that fit inside of 8? What are all of the numbers that would go into 8? Someone tell me a number that divides perfectly into 8. 4 does. Love that for me. Give me another one. 2 does. Give me another one. 1 does. Give me another one. 8 does. Now here's the bad news. Those will all work. So could possibly. So could their counterparts. Right? Now, here's what. If there was a number in front of this guy, like a 3, again, we're not going to worry about that in this class. We would have a whole nother set. We would take all of these guys and also add in 1 divided by 3, negative 2 divided by 3, 4 divided by 3, negative 8 divided by 3. Will we have to do that tonight? We will not, right? You want it, you don't want to do that, right? We're just doing the 1. We're just doing 1 tonight, right? Now, here's what. You're thinking to yourself, what does she mean? Does it work? And here's what. We're going to check out these numbers. Now, I'm telling you this. I wrote your homework assignment, and I made sure one of the numbers that works is in the early group, right? I don't need you to check a billion numbers. But you don't want to check a bunch of numbers either. So right now, I want you as a table group to decide, and you're still not sure like what I'm asking you to do. So hold on a minute. To pick one of these numbers, 2, 1, negative 2, or negative 1. Decide amongst your table group. Write it on your table which one you're going to check. Right? 2 different ones, right? Now, you're thinking, what do you mean by check it? Here's what you're going to do. You're going to use synthetic division. And if you get 0, you're going to shout bingo to your table mates because that means that one works. Are you ready? Here you go. 1, 3, negative 6, negative 8. When someone in your table group gets to 0, shout bingo and be like, I got it. No. Good question. It's actually the root. So this 1 would actually correspond to x minus 1. It is, you are testing the root as it is. Good question. Wait, do we have No, because we're actually testing the answer, right? So here's what's nice. Go. Got it? Okay. I want everyone to get a bingo at the table group. It makes sense. I want every table group to get a bingo. I'm confused. Can you help me out? So you're going to test one of those first few numbers, right? So right now, Martin is testing 4.
Oh, so bad.
My God. Okay, so Mosen got a bingo. And Mosen said it's 2. Now I want to be really careful about this. You are actually testing the actual answer. You're not testing the parentheses. So to be clear, Mosen got 2. I'm going to check it to make sure he's right? I want to be clear. Mosen is checking this right now. X equals 2. If he wanted to put that in a parenthesis, it would be x equals negative 2. When we test the number, we're actually testing this. So Mosen says it's 2. Let's try it. 2 times 1 is 2. That's going to give me 5. 2 times 5 is 10. That's going to give me 4. 2 times 4 is 8. Bingo. Now, we now need to find the other 2 answers. We got one of them. I don't want to do it by guess and check. I'm now going to take this guy, x squared plus 5x plus 4. I'm going to factor it. X factoring. Super easy. You know how to do that. You see what I mean? You've given yourself a hint. Now you go to x factoring. So here we go. Factors of 4 that make 5. That's going to be 4 and 1. So here's what I know. I got this guy already. I got this guy now. And I've got this guy now. So my 3 answers are 2 that we got from Mosen, and -4, and -1. Would this have worked if you tested -1? Yeah, then you would have factored to get these other 2. That's what's cool. Lots of different options, but here's what. You don't want to be the one who has to test every single one. You want to share it with your neighbors. Does that make sense? So let's try another one. You ready? Here we go. Squad, where did you go? Okay. -1, -4, and 2. Okay, so here we go. Everyone watching. Liam said the first thing I want to do, this is a 5-parter. I want to see if I can take out an x just to make the problem easier. And you know what? I can't. I can't split it because it's got 5 parts. So I need to have a hint. So I need to test some hints. So the first thing that you're going to do is figure out what are my options. So one option is that the things that go into 9, I don't have to worry real quick. Hold on, let me get rid of that weird thing. Why does that keep showing up? I don't have to worry about that 1, so I'm not going to worry about him. Well, let's think of the things that go into 9. 1 does, and -1. 3 does, and -3. And 9 does, and -9. Now, I'm telling you, I wrote these nicely, so it's probably going to be one of these. So right now with your table mates, split up the work. Don't check all of them yourselves. You check 1, you check -1, you check 3, you check -3.
I got it.
In real life, will you have to do 1 on the test? Will you have to check them all? Or I'll probably make it a 1 because I'm lazy like that? Now, when you get your answer out, it's going to be a 4-parter. Do you know what to do after that, right?
It's negative.
1, -4. Am I hearing some bingos out there? Is it 1 or -1? Is it 1? I'm going to try 1 and we'll see what happens. 1, -3. Oh, what? What? -3, -3, 3, 3, -9. Ooh, that does work. Bingo! Yeah, I'm so happy. Okay, add your x's back in, right? We know what to do. We've been doing this now. To the 4th. No, is it to the 3rd? To the 3rd plus x -3 to the 2nd. To the 2nd plus 3x plus 9 equals 0. If that's scary for you, you can write it out a second time so it looks good. 1x to the 3rd minus 3x squared plus 3x minus 9. Hey, that's a 4-parter. Cut them in half, right? We're pros at this. Boom. X squared, x minus 3, taking out a positive 3, x minus 3. Yay, they match. That makes me happy. So here's what I've got. I've got x squared plus 3. I got x minus 3. I know that 1 already works. If I want to include him, I can, but I already know he works. Yay. So here are my 4 answers. Let's find all 4 of them. Number 1 is going to be 1 because I got him right over there. Yay. Let me get rid of these. Yay, yay, yay. I also know I am going to have 3. Where did I get him? Right there. And that last one, remember what we do there? X squared plus 3 equals 0. Move the 3 over. X squared equals negative 3. X equals plus or minus I root 3. X equals I root 3. And negative I root 3. Do I have 4 answers? Yes, I do. Yes. Yes. Why? Because it works. And can you still practice from this? Yes, you can. I know that 1 works, and I know that 3 works, and then those other 2 will funky like with your brain. Okay. Last one, best one. All by yourselves, ladies. All by yourselves. Split up the work. 35, right? 1, negative 1. 5, negative 5. 7, negative 7. 35, negative 35. Would I do 35 and negative 5? No. Would I start with 1s and 5s? Yes. Start with 1s and 5s. All the way through, looking for 5 answers. Jim is halfway done. All by yourself with your paper. With your paper. Share the work. Somebody wants to 1.
Honey, what are you doing?
Yes.
I'll do negative 5. These are 2 more.
Yes. So here's a score. If you had guessed 1, you would have gotten these other ones. If you had guessed 3, you would have gotten these. As long as you get 1 to help you out. So split up the work on this one for 35. You don't want to check all of them. No, but I'm going to make it a pretty easy.
It's definitely not negative 5. It's 5. All right, what does it come out to? One minus 6x.
I got to be early on, my friend.
All right, then what's after that?
Share the workload. As long as you hit 1, as long as someone gets a bingo early, you're good to go.
I got 1 too.
Where's your bingo? Oh, you got it. Now you might get different ones that are bingoing you. That's okay. You can go the next steps, and either way, it will work. That's what's kind of cool on this. But I just kind of race through and say, whoever gets the bingo first, we're going to use theirs. I may steal Emma's because I think I saw it. Or Kenny had 5, right? Kenny's, Emma's like, no. Negative 5, negative 6, 30, negative 7, 35. So I think my friend Kennedy tried 5 and it worked. So here I go. I also think another one works. I think 1 works. Or negative? Yeah? Okay, fine. Here we go. Let's try it. Nice and easy. 1. Oh, look at that, a 0. Oh my gosh. But you're pretty. Another 0. And negative 35. Look at that. It totally works. Now, that's that weird, funky one. Now, we're going to be really careful. We're going to start not at 5, drop down to 4. So let's be really careful on this one. X to the 4th plus 0, x to the 3rd minus 6x squared plus 0x minus 7. That's freaky looking. So I am going to write it a second time clean. X to the 4th. That goes away. Minus 6x squared. That goes away. Minus 7 equals 0. here's my hint to you to keep going. Quadratic form, right? It's like a quadratic, it's like factoring, but remember we split that guy up into 2 and 2, right? And you keep going on this. Yes. You can enjoy it? You gotta wait. Huh? You have to wait until he comes back. Are we ready? So here's what I'm going to get. I'm going to factor this guy. Factors of -7 and make -6. -7 and 1. X squared minus 7. X squared plus 1. Here come my answers very carefully. Are you ready? I know this guy's going to be plus. Liam, you want to go ahead and read me what the answers you got were?
Yep.
Okay.
Plus minus 7.
Awesome. Now I want you to be really careful on this next one because you're going to say something and I'm going to want you to clean it up. So what do you get? What do you think you get on the next one? You're almost going to be perfect. I know. Plus minus root 1, right? What is the square root of 1? Plus minus I. So we want to watch for I root 4. What's the square root of 4? 2. We want to watch for plus minus I root 9, because what's the square root of 9? 3. We want to watch for those, right? Let's count them. 1, 2, 3, 4, 5. That's it. So here's what. I am giving you almost 27 minutes. I want you to work as a team. I want you to get to problem number 1 and say, I'll check this number, I'll check this number, I'll check this number, I'll check this number. Right? That's all. Do this in class. Finish in class. Don't do other work because you don't want to do these by yourself.
Whoa.
So all in the classroom and we just don't get that blue or black that stops recording. I don't know which one of those weird buttons. Try one. Try the blue one.